remember that we started talking about parallel lines, and everything we talk about here is dependent on the lines being parallel. So when we talk about corresponding angles being congruent, alternate angles congruent, alternate exterior angles congruent, same side interior being supplementary, none of those are true if the lines aren't parallel. All of this depends on these parallel lines. Okay, so it says here, state the reason each pair of angles are congruent. This might seem a little bit repetitive, but the main idea here is that the lines are parallel. That's what those double arrows mean, those extra arrows that are in the middle of the lines. It means they're parallel. And then that would give you congruent angles. Now these angles are congruent. And so I'd write, I have parallel lines. And what kind of angles are these two? Do you remember from last week? Alternate exterior. Alternate means they're on different sides of this line, right? They're on different sides of that line, alternate sides of the transversal, and that they are on the exterior of the diagram. Between the lines is the interior. They're not between the two lines, they're exterior. And then you can't forget to say congruent, because that's the main thing, right? If they're parallel, they're congruent. If they're not parallel, they're still alternate exterior angles, but when they're parallel lines, they're congruent. Okay, let's do a couple more. I'll use a different color. So these lines are parallel, and look at these two angles. They make that Z shape when I trace them. Okay, again, it's a backward Z, but it's a Z type shape. It's a little bit hard to see what I wrote there, but it's that Z type shape. These two angles right here, Yalma, what are those called? Alternate interior angles. If you don't know that kind of stuff, then you definitely either need to watch the videos or look up, alternate interior angles, corresponding angles, alternate exterior angles. Again, I write parallel lines implies. This arrow, you say the word implies. It just means that if parallel lines are true, then this second thing that we're writing has to be true. What kind of angles do you call these two? Corresponding. If you look at this X and this X, they're the ones on the right. Okay? They make that F shape. F shape is corresponding angles. We're going to see a lot of those. And again, if the lines weren't parallel, they wouldn't be congruent. The lines are parallel. Oh, I forgot to write congruent on this one. And I got to write congruent on this one. Corresponding angles are only congruent if the lines are parallel. Okay, so I'm moving on. If you got a little behind, you could skip where we were and go to here. There's going to be a fair amount of writing on these problems. And I drew two diagrams that look almost the same. Okay, these are parallelograms, or I shouldn't say they're parallelograms. They look like parallelograms, and they have the diagonals drawn in there. So you have this shape and then the two diagonals. So you have this quadrilateral, two diagonals drawn. I did an example problem. And what I did is I said, okay, I'm going to make these lines the parallel lines. Then I said, okay, if those lines are parallel, this line hits both of those. And then I made that Z shape. And I said, these angles are congruent. And that's this pair. And I'll do these with you, but that's this pair right here. Then I said, well, I can also make a Z shape like this. And that's these pair here. I'll mark them differently. That's this pair. Okay? Now, I'm going to do, now that one I already did for you. So that was an example problem. Let's leave these marks in here. So these are congruent. And these are congruent. You can put that on your diagram. Now somebody might say, look, I can make a Z shape like this. See the Z shape right here? So they say there's a Z shape right there. Shouldn't you make these two congruent? And the answer to that is yes, there's a Z shape there. Yes, those are alternate interior angles, but the lines are not parallel. If the lines are not parallel, the angles are not congruent. So they might be parallel lines, they might be congruent angles, but I don't know that for a fact. This diagram is different. This diagram, these are parallel. So when I make my Z shape, I wouldn't make my Z shape like this because I need my Z to contain those parallel lines. So I'm going to do one like this. So go ahead and make a Z shape with those parallel lines. And then I want to say that this angle and this angle are congruent. When you have that Z shape, it's the two angles in the corners of that Z that are equal. Then you got to label them, okay? So this one down here is FD. Now, you guys tell me, what's the third letter? If I say FD what? G. Can I say FDJ? I could. So I just got to trace that angle. So I can go say FDJ or FDG. Either way, it's the same angle. D has to be in the middle. That's where the angle is. So you like FDJ better? FDG better? Okay. Somebody raise your hand and give me the name for that other angle. The one that it's congruent to. Go ahead, Angel. H, G, D. H, G, D. And again, let me just trace it. If I go H, G, G. Again, don't look where you land. Look what you traced out. You traced out this angle, and that's what we're talking about. That one's congruent. Okay, then I erase all that. Okay. So I told you it's a little bit better to have this in pencil. I guess I should write the reason. The Z shape is always alternate interior angles. So you write that same reason I wrote in the other problem. Parallel lines by the alternate interior angles congruent. Okay, now I'm looking for a different pair of alternate interior angles. So, I'm gonna write these two down again, but without all the lines that I drew. And then I'm gonna do this again. This time I'm gonna do a different Z shape. Okay, so like this. So one of the diagonals is a transversal, the other diagonal is a transversal, and so I'm doing this other diagonal. All right. Does somebody think they can name both pairs of angles that I'm about to say are congruent? You know, I can't just say F and H. I can't be like F and H because there's multiple angle Fs, right? Angle F, we don't know which. There's three different angle Fs. So I can't say F and H. I can use three letters. Anybody think they can do this? All right, Alyssa. DFH, let's mark that down. If I go DFH, again, some people are still not sure about this. When I go DFH, don't say, you know, DFH is over here. It's not. DFH, when you trace it out, you're tracing out this angle. I'm going to put two lines on there. DFH is that angle. Okay, let me get rid of some of this to beautify it. So that's this angle. And I think, Alyssa, you said GHF. And the H has to be in the middle. If you said FHG, that's the same thing. Whether you say GHF or FHG or JHG or GHJ, there's four different ways to write that angle, but it's got to be talking about that one. Okay, and let me explain the difference between these two problems again. Okay, these lines are parallel. Here, these lines are parallel. These ones might look parallel, but I don't know they're parallel. So that's why I ended up with different angles there. When you make the Z shape, the top and bottom of the Z have to be parallel lines. Okay, again, it's not always a Z shape. The Z shape ones, alternate interior angles, are the most popular. They're the most frequently used, but it's not always that like that. Okay, let's do another one. Okay, so what I'm telling you is look for the parallel lines. Then look for a transversal. A transversal is a line that hits the other two. For congruent angles, you wouldn't look for the ones that make the U shape. The U-shaped ones are not congruent, they're supplementary. So if you're wondering like why I didn't do the U-shaped ones, it's because those add to 180. That's true that they are 180, but this one specifically says find all congruent angles. So I'm not using the U shape because the U shape doesn't give me congruent angles. So in case you're wondering why don't I use the U shape, when I draw this F shape like this, in the F shape, it's the ones that are like this that are equal. Those are corresponding angles. It's this one and this one. So I would say angle, can I just call this angle V? If somebody said angle V, is there any other angle that could be V? No. If you want to be safe, use 3 letters, but you could just say V. I'll say XVZ, but you could call this one angle V. Could you call this one angle W? I call this angle V because there's only one angle here. But for angle W, I could be talking about this angle, or I could be talking about this angle. So when in doubt, use 3 letters. For angle W, for that angle that we're talking about by W, you have to use 3 letters. Y, W, Z, or Z, W, Y. You have to talk about those 2 angles. And then the parallel lines, that was these 2 lines, is why the corresponding angles are congruent. Corresponding angles make that F shape. Whenever it's that F shape, it's corresponding angles. All right, you find the other pair of angles. Ash, you got a question?
For the first angle, for angle B, could you use XVW?
Yes. Yeah, he asked about XVW. So as long as V is in the middle, you're probably doing it right. So it could be XVW, it could be XVZ, it could be ZVX, it could be WVX. As long as V's in the middle, it's really hard to do that wrong. So for the other pair, I want to use a different transversal. So the other line that hits both. Okay, this one would be like a backwards F, but it's still those 2 same locations tucked into the corners of that F like that, however you want to describe that. They're called corresponding angles, that's the name for them. It's this angle and this angle. And just to save us time, I'm just going to do this. You may have not written it exactly like me, but your X and Y should be in the middle. And then the reason's the same. Parallel lines imply corresponding angles, congruent. You could have different types of angles in the same diagram. Everything we do from here on out is going to be some kind of combination of these ideas. Number 3 says find and label each angle measure. And if these lines weren't parallel, you couldn't find all of these angles. But if the lines are parallel, which they are, that's what those double arrows mean, I only need one of these 8 angles, and I could find all the other ones in here. So there's 8 angles there. Once I have one, I can find every other one. And don't forget about some of the old ideas that we've had. So the angle down here is a vertical angle. So don't forget that vertical angles are always equal. So those are both 96. This is upper right-hand corner. This is upper right-hand corner. Those are equal. Those are corresponding angles. These also make that Z shape. So these are alternate interior angles. There's one more that's 96. Try to put it down before I do it. Some people would label this 96 because they would say these are vertical. Some people would say that's 96 because these are corresponding. Some people would call that 96 because these are alternate exterior angles. So there's 3 different reasons why that one's 96. If those are parallel, those 4 are all equal. and the other four are all equal to them, but they're not, are all equal to each other, sorry. The other four are all equal to each other. So this angle, this angle, this angle, and this angle are all equal to each other. They're just not 96. Everybody figure out what those are? Yell it out. 84. Now, you have to figure out one of these 84s to find the other ones, but they're all 84. We'll talk about why they're 84 in just a second. Go ahead and label them all 84s. What do you call a pair of angles that are next to each other like that? Do you remember the name? Linear pair. It's a pair of angles. They form a straight line, a linear pair. Those always add up to 180. So there's a linear pair there, 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 there's a linear pair here, and here, and here, and here. There's 8 linear pairs there. The other ones, and this is the new thing, and you absolutely have to know this. What do you call those pair of angles? Those are not a linear pair.
Vertical.
No, they're not vertical. Vertical are equal. Same side, interior. And the same side interior are always supplementary, so those add up to 180. These are same side interior, those add to 180. So that's another way you can know that. Once you know one of those, you can find all the rest. Okay, let's do problem number 4. Problem number 4 has some algebra in it. And you know what I'll tell you on these is, when they give you 2 angles like this, either they're going to add to 180 or they're going to be equal to each other. And if you're guessing, you're going to get half the problems wrong. Either 2 and 3 are equal or they add to 180. And like I said, if you're guessing, half the problems will be wrong, half the problems will be right. It's just a mistake that one of these has a degree symbol and the other doesn't. They're both in degrees. So I don't know why one of them has the degree symbol and then one of them doesn't. It just is a mistake. It really should be written like this. Parentheses with the degrees on the outside, parentheses with the degrees on the outside. It's not that important, but okay, what do you think about angle 2 and angle 3? Are they equal to each other or do they add to 180? Because if I pick a random pair of angles, right, we already said that any random pair is going to either add to 180 or be equal. And you need to know that. And then, you know, you can just look at 2 and 3 and you could say, like, you know, do they look equal or not? They should look equal. What kind of angles are 2 and 3? Corresponding. Now, I said that they're only equal if the lines are parallel. I don't have the markings on here. How do I know they're parallel? Because it says it right here. Let me see it. Okay. I don't know. I just got to point these things out to make sure. If it didn't say that, if this was not written down, this problem would be impossible. Okay, so it says they're parallel. So when you see this written down, you can go on the diagram and mark those arrows. So mark those arrows on there. Those arrows mean these are parallel. And then, whoops, these are corresponding angles. And we said, if the lines are parallel, which they are, then the corresponding angles are equal. Okay. The problem says to find angle 1. Okay, but we can't find angle 1 until we find, you know, x. So we're finding x right now. I have an x on both sides. I have to move one of these over. Get the x on one side. Now I'm getting x alone. These could come out to be fractions or decimals. This one comes out to be nicely equal to 17. All right, so that's my answer, 17. But that's the final answer?
No.
Okay, you got to watch out for that because some people get that x and they're like, I got x. Yay, I'm good at algebra. And, you know, that's nice. Even if the problem said, what is x? I would still plug it into both of these to see if they're actually equal. The thing about this is if they're not supposed to be equal, this number will make them equal. If I think they're supplementary, this number, you know, will make them supplementary. So just because your answer makes it, you know, the way you think it should be, it doesn't really mean that you set the problem up right. It just means that you solved what you set up right. So if I set up the right thing, this is the right answer. If I set up the wrong thing, this is the wrong answer. So plug it in only checks that you solved that correctly. It doesn't really guarantee that you set the problem up correctly, but it guarantees that if that setup is correctly, that is the right answer. I get 105. So this is 105. This is 105. What do you think angle 1 is then?
105.
You think it's also 105? And what kind of angles are 1 and 2? Those are vertical angles. So I could say that. Another way I could do it is to say what kind of angles are 1 and 3? Alternate exterior and alternate exterior angles are congruent too. So I could have done it that way. Most people do the vertical angles. This is 105, and by the way, this one's 105 also. So there's 4 105s in there. All right, go to the next problem. So this is a little bit challenging. They're asking you to find x and then find y. And that shape is a parallelogram. If you don't know it's a parallelogram, that's okay. But a parallelogram is a quadrilateral, right? 4 sides, where it's got a pair of parallel sides and another pair of parallel sides. So opposite sides are parallel is a parallelogram. So that's a parallelogram. When we do parallelograms, we do these same problems all over again. And so if you learn it now, it just makes the parallelograms easier because parallelograms obviously have parallel lines. Okay, so do you think I put all 3 of these into one big equation? No, you never mix x's and y's. So I want to have an equation with just the x's. I can't find y right now. It's impossible to find y. I can only find x right now. All right, what do you think about those 2 angles? Are they equal or do they add to 180? I want of each here. Do they look equal? Like if you were to actually get out a measuring tool and measure these angles, you get out a protractor measures, do they look equal? Okay. So let's look at the shape that they make. I got, this is the transversal, and these are the parallel lines. So these are the parallel lines I'm talking about. The parallel lines are the 2 lines that don't hit the angles, and the transversal is the one that does hit the angles. So I'm not using this parallel line at all. I'm just looking at this part of the diagram right here. So those angles are like this. What do you call those kind of angles that make that U shape? Same side interior. And the same side interior, the U-shaped ones are supplementary. So, it might take people a while to get used to this, but like I said, either they're equal or they add to 180. And you can't be guessing. You have to know. And the ones that make the U shape are supplementary every single time. It all relies on there being parallel lines, but these add to 180. If you're too lazy to do all the homework, which hopefully you're not, there's 3 homework assignments, but at least go through and say, are these equal or 180? Equal or 180? Equal or 180? And just make sure you could do that, because if you could set them equal to 180 correctly, or set them equal correctly depending on the problem, you'll be able to get most of these right. The people who set these equal, they write this equals this, they're going to lose most of the points. The whole problem's not going to make any sense. Okay, anyways, these x's are on the same side of the equal sign. The equal sign's over here. I'm going to have people who do this. They're going to go minus 10x, minus 10x. Look where the equal sign is. Okay, you wouldn't subtract 10x from the same side of the equal sign. So you don't do that. If they're on the same side of the equal sign, you just add them. 12x and 10x is 22x. 7 and 52 again, just to add those numbers together, you get 59 equals 180. Now I'm going to subtract 59 from both sides. Now I'm going to move things away. What does that equal to? 121 divided by 22. What is that, 5.5?
Yeah.
I did it in my head. All right. So 5.5. Now again, it's a decimal. That's not a decimal. It's too difficult to work with. Let me say this again, because I want you to understand this. If you think they're equal, and you set them equal, and you solve, the x you get will make them equal. So by plugging this in, that is not checking that you did the problem right. Okay? It'll only check that you did the solving right. So if I have the wrong equation, I will get the right answer to the wrong equation. I need to check to make sure these add to 180 now. So I am only checking that I did the solving of my equation right. This doesn't actually tell me whether I have the correct equation to begin with. I think I have the correct equation, because I know that these are supposed to be supplementary. I should get 107 here, 107. You see how those add to 180? Okay, that's what we said. We said they have to add to 180, and those add to 180. They're not equal. It's possible they could have both been 90, and been equal, but I got 5.5. So x is 5.5. How am I supposed to find y? Because, I don't have another one. I know that, let me use a different highlighter. I know that these two add to 180, but I got nothing there. Anybody have a theory of what to do here? Any ideas? Maybe you don't know what that y is, but do you know what the measure of this angle is right here?
Yeah.
Isaiah?
Isn't it 107?
107. Yep. And let me explain why. Okay. I'm going to use a different pair of angles and make a U shape. Let me get rid of the highlighting here. See that U shape there? That U shape is a different pair of parallel lines, a different pair of same side interior angles. These two have to add up to 180. And I get 107. So I know it's 107. So should I just write down 107 then? See, I know that angle equals 107, but I don't know what y is yet. I know that y has to make them 107. So I say, I need to find the y that makes it 107 because I know it's 107. This is not the only way to do this problem. I could do 73 plus that angle equals 180. So if you're thinking of that would work too. It's just easier to do it this way. It's the same. So I add 5 to both sides, divide by 8. Did anybody figure this out already? What's 112 divided by 8? 14? 14. Okay. Guaranteed you'll see that kind of problem again. No doubt about it. And it is a major type of problem to be able to understand in geometry, that consecutive angles, the ones that are next to each other, add to 180 in a parallelogram. Same side interior, another word for that is consecutive interior angles, the ones that are next to each other. Okay, so read number 6. Write down which angles you think are congruent. You don't have to explain why, but there's only one pair of angles. See if you know which ones they are. So those lines are parallels. You should mark them down. Those arrows mean they're parallel. When those are parallel, this doesn't mean they're the same length. Like AC and BD look like the same length, but I don't really know that they're the same length. Parallel means that they're parallel. It has nothing to do with them being the same length. So when you mark these down, you don't really know which one's shorter or which one's longer. Now, a transversal could be any line that hits both. Now, this could be a transversal because it's hit both lines, but that makes that U shape. U shape makes things supplementary, makes them add a 180. U shape here, that's supplementary, adds 180. I need to find either the F shape or the Z shape for these kind of problems. There's the Z shape with the parallel line. It's the only way to make that Z shape. If you're saying, well, I can make a Z like this, that's not with the parallel lines, and that doesn't make any sense because there's no line there. And again, that's not with parallel lines either. The Z shape, the top and the bottom of the Z have to be parallel lines for these to be equal. And it ends up being angle CAD, and somebody yell at the other angle. It's hard to hear what you said. BDA, okay. I wasn't sure if I heard D in the middle or not, but BDA, AD, B, it has to be those pair, okay? Again, you might say, you know, there's a Z shape right there, but no parallel lines. So those angles are not congruent. It's got to be the Z with the parallel lines to be congruent. All right, let's do another problem. I got two pairs of parallel lines. I have different angles here. This is not always an easy problem for people. I have a right angle symbol in there. Okay, that's nice. I'm gonna have to use that too. Here's another one where you have an X, and a Y. You're not plugging all those into one specific formula all at once. Okay, so let's look at the two of the X's. You need a reason why they're either supplementary, they add to 180, or they're equal to each other. And again, you don't want to be guessing whether that is true. What do you guys think? Do you think those are equal or add to 180? What do you think? Okay.
I said it was equal because they're corresponding.
They're corresponding. It's not easy to see that they're corresponding. So again, what you want to do is trace out the angles. So if I trace this angle, and I trace this angle, do you see how they make that F shape? That's corresponding, okay? And then in the F shape, it's got to be the two parallel lines being the, you know, like the parallel parts of the F that are parallel, and those other angles are congruent. So these angles are congruent. So you set them equal to each other. They're not always equal, okay? And when they make the F shape or the Z shape with parallel lines, there's always with parallel lines, then they're equal. Here the X's are on different side, I'm gonna move one of them. When the X's are on the same side, just add them. When they're on different sides, you move one of them. You could do minus 3x to both sides or minus 5x to both sides. You get 22. When you plug that in, that gives you 70. Let's do 5 times 22 minus 40. That should be 70. Oops, I have a issue in there. Okay, 70. Just making sure. I got 70 for both of them. Okay. Now I have to find y. The whole problem says find y. The x wasn't too hard. Anybody have a strategy for finding y? Any ideas? I know that this angle's 70. I know that angle's 70. Anybody find anything else in here? Which one's 90?
Oh, I don't know.
Oh, okay. Well, I know this one's 90. right?
Yeah, that's what I'm
Okay, but that's not really a new one. I need something that I didn't know. Got it, yeah.
Would the top be 90?
This one?
Yeah.
So you think this one might be 90? Here, like this? Do you have a reason for that?
Because it makes like the Z.
So when you make that Z, you need parallel lines. And we do have parallel lines, right? Those two are parallel lines. So that does equal 90 up there. So I could have a 90 here. Do you guys think that this one's 90?
Yeah.
Same type of thing. I have the Z shape, and that one's 90. Okay. All right. I got those 90. All right. Does anybody think I can find this angle right here?
It's 20.
Anybody want to raise their hand and tell me what they Grant?
20.
20. It is 20. And that's because all the way across here has to equal 180. So 70 plus 90 is 160. I need 20 more. The other way I could say that is in this triangle, those three angles have to add up to 180. In this triangle, these angles have to add up to 180. So this one's 20. Also, I could say this one's 20 because what kind of angle are those two angles? Those are corresponding. Okay, so I know that's 20. Is 20 the answer?
No.
No. But I know the 3y plus 2 has to equal 20, and now it's just a matter of solving this. So there's more than one way you could have found that 20. We talk about multiple ways to find the 20. But you have to use that right angle as part of it. 6 is the final answer to the whole thing there. So here's what's going to happen tomorrow. Tomorrow we're going to do the next notes. Then we're going to go over any homework questions you have tomorrow and on Wednesday. And then Wednesday you're taking a quiz. It'll be a short quiz, but it'll be a quiz nonetheless.